We come into a stand, which may be a very large stand. This one is relatively large, and then we establish what's called a permanent plot, which would be a subset of that stand, which is marked off 25 meters on one side by 25 meters on the other side. And then we tag the trees so that they're all inventoried and labeled, and then we measure the tree's physical characteristic, each tree within that permanent plot. And then we have, for that permanent plot, an estimate of the amount of carbon that's in that plot, and then we can take that estimate as a sample and extrapolate it to the whole stand, okay? And that's how we kind of go from a small point to a large stand, and then we use the satellite imagery to go to a whole landscape and get that done over a very large area.
And then once you have that information, what do you do with it?
When we have that information, and we do this every year because the site is growing, it's accumulating carbon as these trees get bigger and bigger, and as we do that, we can then put into a database, a computerized database using geographic information systems on the web, Google Earth, whatever you're thinking of, and record that information and then report it to a carbon market where carbon is trading. So we can translate this amount of mass into the amount of carbon that's removed from the atmosphere, and for every 100 tons that are removed, we can sell it at a price in the carbon markets as an offset. And then that sale, if you will, comes down back to the farmer or the community as a sale for a particular commodity, which in this case is carbon.